Television has certainly been a passion in my life since I was probably yay high, and yes, 30 years ago in my parents' basement or so is that I got my first taste of television, and I wanted to learn much about it. It became my career as an engineer, working in the post-production industry and motion pictures, but I also loved the idea of history of television. It was always wanting to know how things started, where did things come from, what was the start of it. It was fascinating to me, and when my boss, where I work now, gave me a magazine that had an article on television used during World War II to guide missiles. I'm saying, guide missiles? I thought that there was a black hole in time where television came out in 1939, the World's Fair was introduced, and then suddenly it appeared again in the late 40s with, how do you do the commercial television. So I never heard of such a thing. So I was fascinated. I talked to other people that were similar, technical and historical people. I said, you ever hear about television guided missiles? I said, no, I never heard about that. So I wanted to know more. And then I started found the first camera, started finding all the pieces, got more and more thrilled about it, interested in it. So also no one else was interested in that part of history or even collecting the pieces. It was such an important part of history to preserve, and I said, well, I guess I should be the one. Someone volunteers. I had the collector gene in me, so I started collecting all the pieces, started interviewing all the people that were involved, learning as much about the history as I could, and today you get a little sample of that here. So what I'm going to talk about today, and I'm going to try to keep a little bit brief on the technology, two aspects of this. One is the development of the technology itself for the weapons, and actually the second part will be the weapons themselves that use television during the war. Here is a sort of a tree of all the activity of manufacturers and systems that were used during World War II. And of course the print is very small. There was a lot of activity, a lot of manufacturers involved. There were a lot of programs taking place. It was a hotbed of investigation. The purple on the map here is actually what I'm only going to talk about today. And I'm only going to talk about it in brief because I could spend a week here talking about the compass of all the technology involved with television during the war and its many applications. So RCA was one of the main contractors for these television systems, and they developed 3 systems that were used during the war. Actually, and I say really more, 2 of them. One was still in prototypes phase until the war was over and it wasn't used. And also, they also used code names for everything. Everything had a code name because they wanted to keep all the projects very secret. In fact, I was talking to someone earlier that they never even referred to the cameras, TV cameras, as TV cameras. They always called them conversion units. So there was multi-levels of security in coding to kind of sort of keep this under wraps. So the first system that was developed is called the block system, and that was used in guided and powered missiles. The MIMO system came a little bit later in the war, around 45, and that was a miniature version of the equipment you see over on that table there to actually fit into the nose of a weapon, sort of like the way electronic fuse sat in proximity fuses in weapons. It was very small, came late in the war, wasn't used. The ring system was used, and it was used in the Japanese theater, and that was the idea of using television for reconnaissance. So you had a plane in the South Pacific area that had television cameras and high-powered transmitters that could relay the operations of, say, the Japanese fleet from a high altitude to the operations ships further back, and that was used, I believe, and that was used during the war on a couple missions. But we're not going to talk about that. We're only going to talk about today is the block system. The man that actually kind of brought this all together was Vladimir Zworykin, and Vladimir Zworykin worked for Westinghouse, and he invented the iconoscope tube. And the iconoscope tube, which is sitting on the table back there, was the imaging device that actually made electronic television possible. He did have a, there was a competitor to Farnsworth, Farnsworth was a competitor to Zworykin, and he also had a tube, but his tube was actually not very efficient, not very good. His tube actually won out in the basis of quality and sensitivity. RCA, he merges in with RCA and writes a memo to David Sarnoff in 1934. And the basis of this memo is that he foresaw, how he foresaw it, can't quite figure that out, that the Japanese were developing a suicide core for guiding bombs to targets. Have a man in a plane, have that man aim that plane right to the target. You couldn't get any better accuracy on a guided weapon than human intervention. Knew that obviously the Allies or the U.S. could never have such a system ourselves. Thought in his probably more of his business hat, if we use television in the idea of in the place of the pilot, have the operators sit in a safe location, controlling the bomb remotely, you can see out the nose of the bomb. But with television, that should give the similar level of accuracy as what the Japanese were working on. And this was Zworykin's concept of the bomb, and this is 1934. And if you see in the beginning of the head of the bomb right there, you'll see that there's a television camera out the nose. It has, wings, so it's more, it's probably more meant to be a glide bomb, except there is a little propeller in the back of the weapon. Maybe it was also thinking of concept of a powered bomb, so either powered or glide. He was coming up with this idea. Sarnoff loves this idea. Then, businessman that he was, and actually here's a little, well, skipping ahead, but actually here's a kind of the little schematic diagram of what the iconoscope looks like. If you're interested, I can actually talk about it later, how it actually works. So Sarnoff, being the businessman he is, starts going a campaign to the Navy and to the Army of selling the concept of television-guided weapons. He's in essence putting on his business hat, and you'll see here, this is this is still in 39, so he's still selling from 34 to 39 this concept of television-guided weapons. He's not getting very far. In fact, you can see here, this is to the Army Air Force in right field, and here's the same actual letter, carbon copy, stamped letter going to the Navy. Still trying to pitch and sell the idea of these weapons. So on Sarnoff's own pocket and RCA's own money, they start paying for their own tests and development. So in 1937, they start developing very small television equipment that they could put into a Ford tri-motor aircraft with transmitters in the plane. They have these TV cameras out the sides of the plane and transmit a picture to the ground all electronically. This was actually the first, and they demonstrated this to the Navy and to the Army and to all the military bodies of we can actually transmit a picture electronically from the air to the ground, sort of selling a concept. Services liked the idea. They ended up creating a military version of what they did of this 1937 version, and its code name is the Jeep. So the Jeep system was a fairly large system, again fitting into this relatively large plane. It's 340 pounds of equipment, and it was basically built for concept, selling the concept. We can actually do it. We can, we progressively make the technology better. Here's a demonstration of what we can do. And you can see some of the equipment here. In fact, if you look at the set here, it's 1940, it's actually very similar set to what was used in the 39 World's Fair when they unveiled television there. It's a very similar with the glass in the lid set that they sold commercially. They started taking commercial electronics that they were developing for the public and actually militarizing it to use for these weapons. So he was using all the resources of RCA to sort of make a military version of this technology. And these are the transmitters that were used. So they ended up liking the concept. They ended up selling. The Navy was probably one of the first divisions to be able to pick up a contract with RCA. And they developed the first system. And the first system was known as Block 1. And Block 1 came out in 1942. Just a quick little technical breakdown of the television, military television during World War II, and versus what commercial television is, which was NTSC, which was the television system we had over the airwaves. And you had an antenna before you had HD. NTSC was what was the common broadcast system here. So and you can see that basically it was the quality. There's less frame rate. There's actually less lines. The quality was meant to be much more reduced than commercial television, because the idea was for military television, size makes a difference, keeping the costs down, keeping the amount of tubes and components and weight down, because the quality didn't need to be perfect. It needed to be just good enough. You need to be able to identify objects, identify silhouettes, be able to identify a general sense of the scene, not to have the detail of seeing every nook and cranny. So it was more of a much more scaled down system than commercial television. So just quickly to the first television camera here. I'm not going to go into too much of the details, but the Block 1 camera had it was a camera, it had a camera and transmitter built into one. So that was an idea, it was a great concept, but the transmitter and the camera in one housing sound good in concept, but in reality it actually wasn't very good, because they tended to interfere with each other, and the subsequent models, they kind of got away from it. But it was actually built in quite a bit of quantity, because the Army, the Navy, and all the other the research divisions were buying up these cameras from RCA and starting to do experimental testing to see what could we do with television. It's very interesting. I sort of surmise that today where you have the cell phone, you have computers, the technology is so intense, and developers are thinking what kind of apps we can create to use with this cell phone, because it has so much ability and so much capability. They thought the same way television back then. It was so new. What could we do with it? And they were using that as a form of experimentation. The receiver was similar thing, was came up with a receiver, and unfortunately it was also a single channel receiver, where the one camera could only talk to one receiver. Much later in the war, like you see back there, they had the ability with a tuner to be able to tune to different channels, to have up to there, you have 10 different bombs in the air and be selective of which one you can control. The idea of a television tuner didn't quite exist in that sense. So it was the start of that. They sold them out. RCA, sold out all their sets. They came out with another contract, which is how the services place orders for equipment. They made another run of those cameras and made a little more improvements of it to just get them out there, have all the divisions and keep testing away. So in 1943, when they sort of learned from all this testing and the electronics that was out there in the field, there was a lot of problems with it. Things didn't work. It was a work in progress. Technology kept evolving at magnitude's pace. Since the start of this, things were being improved and invented, practically on a daily basis, and they kept improving the system. Says, okay, we're coming out a whole new level of block equipment, is what you see back there, of all the improvements that they learned from the first set into the later, so now maybe it could be used in combat. It's more reliable. And you see here, basically, so what they did is here in this camera back there, you see that they separated out the transmitter. The camera was much more reliable. It was they put more better construction techniques. Took all the improvements that were the problems of the original cameras, improved it into the version you see here. Transmitter, they separate out the transmitter from the camera. Since they separated it out, they could actually make it a little bigger. They also had the frequencies of the technology were getting better. So instead of the original cameras were at 100 megahertz, the later ones at 300 megahertz. So you get much better picture quality. It can transmit over longer distances. It improved the situation many-fold. The receiver here, you can see the receiver. If you look here, they had came out with the ability to have a tuner in it. In the receiver, the first set of receivers came out, were only 5 channels. The later ones in the war, which back there is actually up to 10 channels. And they had the monitor, came out a separate monitor for the bombardier. That was, again, we'll talk about that, how they actually controlled the bombs a little later. Kept improving, 44, they kept improving. The next generation of sets came out. You can see here 10 channels were made available, and kept improving the technology almost month by month. And again, they kept coming out with different versions of the camera. One thing you'll see is that on the film, you'll see a little later, is that they end up having a mechanical, they put a shutter in front of the lens. The bomb is sitting on the field in this plane with the lens, pointing out on the base of the field. Sun's rising up from the, or sun's rising up in the dawn. Well, it happens to be that if you point the bomb or the plane's pointing the right way, you catch the sun into the lens of the camera, burned out the tube. You would actually not know it's burned down until you actually go up in the air, drop the plane there, and suddenly look at the image, the bomb, and I don't see a picture. And they sort of realized, okay, we're going to have to put a little bit of shutter in front of the lens when we're not using it to kind of cut the light out. That was one of the things that they learned. And you'll see here another invention that you'll see in some of the footage coming up, the idea of telemetry. They actually mounted a compass on top of the camera and be able to show the heading of the bomb. And you'll see it as now was probably the first use of telemetry in a weapon. So the first versions of the camera, and you'll hear later on about with the shutter. They had a mechanical shutter on the front of the camera, and it was driven by a motor. They learned again when they bringing these bombs up to 15, 20,000 feet. It's pretty cold up there. And what happens is the motors would freeze. And they generally would freeze with the shutter closed. So they dropped the plane, they dropped the bomb, and suddenly they try to go to the remote control, because these would be remote control, these shutters from the mothership. They couldn't get them to open. So they were stuck closed. So they had to, and they lost weapons that way too. They redesigned the shutter, later on. So it kept evolving almost month by month. Everything they learned in the field, they kept improving the weapons, and the technology in the weapons, right up until the end of the war. The transmitter there, 10-channel transmitters. The receiver here, again, you see it's 10 channels instead of 5. Won't cover that too much. Just a little bit. So they had, the Navy had its own version, the Army had its own version, different nomenclature, different systems. We have to standardize this even amongst, as a whole military. And then they came up with the whole military nomenclature called the AN system. And most of the equipment you see here has a tag AN-something. And AN stands for Army, Navy, / and with a very defined code of exactly what that piece of equipment is. So there's no more some ambiguity of the Navy having their own thing and the Army having their own thing, and because they would want to be able to interchange components from one service to another and not have any type of confusion. So here on this later version of the camera, instead of having a motor for the shutter, they had actually a solenoid. Solenoids didn't seem to freeze. And they also came up with the concept of having an orange filter in front of the lens, because also when they set these cameras up, they didn't have the ability to change the exposure. You know, most of the modern camera you see here, if the light changes, the lens or the level of the gain will change in the camera to compensate for the light. They couldn't do that at the time. Technology was invented. You sort of preset it. If it was going to be a bright day or a hazy day, you preset it on the ground for the conditions that the camera was going to run under. So then, of course, if you're dropping a bomb and you're up in there, suddenly it changes from a clear day to haze or cloud cover, you sort of lost all your picture. So they came up with the concept of having a filter that would go in front of the lens to basically cut the light. Controllable from the operator to cut the light down so they can bring back a picture. And that's the receiver. We'll get to that. So early in the war, they realized that the iconoscopes, even though Zwilkin's tube was a tremendous improvement of technology over whatever else was existing, it really wasn't very sensitive. It needed a tremendous amount of light for it to work. And it says we have to come up with a better way of having a much more sensitive tube to use. And they got the military, son up being businessman, got the military to fund the development of this tube. And the tube was developed by these three people, Paul Weimer, Albert Rose, and Harold Law, developed this tube called the Image Orthicon. And that long tube sitting at the table back there. And that tube, they basically took all the technologies of all the various tubes that were developed, in development, all these various principles, and combined them into one tube. And that tube is on a magnitude greater in sensitivity than the iconoscope that it was going to replace. The RCA labs, so they started out, RCA labs started making the first prototypes of that tube, and it came out in 1944. They were all handmade, tremendously complex tube. That's the one that's sitting there with the black ring. Tremendously complex tube. Had a contract with the Navy to make 100 cameras using that tube. Navy loved anything that seemed like new in technology, better, greater, more powerful, and kept funding it to actually make a production version of the block equipment that could be used during the war, so they can do missions that were in darkened conditions or in hazy conditions or in low light conditions or practically moonlight conditions, that the camera tube is actually sensitive enough to work on the moonlight. I won't talk about how the tube works much later, but it is a very complex, it's actually the most complex vacuum tube practically ever made. So this is the camera. This is the version before the camera you see in the table there that used that Image Orthicon tube that they practically, again, only made a handful of them for testing. And then the production version that came out in late 44, early 45 was the version you saw back there. It was developed during the war, but actually saw very little service because they had so many other cameras, the block cameras, they made thousands of those cameras during the war. These were in the hundreds, so they were, didn't get into the pipeline to be used during combat, but they certainly were used much later in the post-war war and into the 50s, when the block actually was decommissioned. If you really want, and how I work with, I have some books that were actually on the table there that actually feature a lot of things about guided missiles. This man, Bart Everett, who works at the San Diego Robotics Lab, who's a historian, is actually coming out with a book. I helped him collaborate on some of the TV technology on a 600-page book on the history of unmanned guided weapons from World War I to World War II. Just covering that one topic, and 600 pages. So it's a pretty intense reading if anybody's really interested in these type of weapons. And it's supposed to be coming out very soon. But before Zwokin's letter to Sarnoff about this kamikaze, of course, the Americans were working on controllable weapons, and the Kettering bug from World War I was certainly probably the earliest start of it, and the idea of having a bomb with a motor on it, and in this case there, and presetting the controls so that it would actually fly into a target, into a heading, was really practically the start of it, and certainly his book will cover from that point 600 pages worth until the end of the war. So again, we saw that there was two types of guided weapons that we used during the war. One was a glide bomb, and the other was powered. And again, mentioned the idea of the glide bomb. It was meant to be dropped usually from a belly of a plane, usually B-17, and had a TV camera and a payload of a 1,000 or 2,000 pound bomb. And then they would use a remote control to guide it to the target. Power bomb, instead of being glide, was had an engine on it. It had a payload, had a TV camera out the nose, and it was either launched from a field or I don't think they actually launched any from aircraft carriers, but most of the time they really launched from ground, put up in the air, and then aimed to the target by remote television. So here is the first of that.
Here we see such a bomb. The General Motors power-driven bomb, 1,400 pounds of potential death and destruction. At Muroc Dry Lake, the bug, as the device has been dubbed, is hoisted by a portable derrick, and the launching car pulls underneath. In these tests, the bomb will be released from the launching car to simulate conditions existent if it were released from a control plane in flight. The launching car was specially built for these tests. It is powered with two 165 horsepower Cadillac engines. Each engine is connected through fluid flywheels to the drive shaft. With this special construction, it is possible to accelerate the car to a speed of 100 miles per hour in a space of 1,500 feet when fully loaded with the controllable bomb. With the bug fastened to the launching car and the release mechanism checked, the hoist is unhooked and the derrick moved away. At a prearranged spot, marked on the takeoff course, the driver of the launching car releases the small plane by means of a release lever attached to the mounting posts. In flight, the plane is directed by means of a television image, which is picked up by the television camera in the bomb-like appendage beneath the fuselage of the bug. This image is flashed on a screen in the control plane. Now, before the trial flights begin, the car turns and drives partway down the track, where the bug will receive a final check on instruments and radio television equipment. Here, technicians pore over the controllable bomb, testing all the mechanical controls. The control ship, in this instance a B-23, is sending out a series of radio signals to enable the technicians to observe the reactions of the small plane's controls. The 3-axis gyro stabilizers, which aid in controlling the bomb, are checked and set. The television camera and equipment are given final adjustments, and the controllable bomb is ready for the test. During these tests, you will hear the actual radio signals which controlled the bomb, and the two-way conversation which took place at that time. The tone you are now hearing is the radio tone modulation signal being sent from the B-23 control ship to increase the throttle on the controllable bomb and bring the engine up to flying speed. The launching car races up the track at 102 miles per hour. And the bug makes a perfect takeoff. On this flight, the follow-up ratios on the spoilers and the rudder have been reduced from previous flights. The GM controllable bomb is controlled in flight by spoilers instead of ailerons. It is equipped with 3 gyroscopes, 1 directional and 2 roll gyros to aid in balancing the tiny craft. All 3 are in operation now. In level flight, such as you see here, the controllable bomb's average airspeed is 150 miles per hour. At full throttle, approximately 180 miles per hour. As the bomb flies along here, the control ship follows a few miles behind and off to one side. In the co-pilot's seat of the control ship sits the man who guides this flying bomb by means of varying radio tones transmitted between the ships. Directly in front of him is a television screen which gives an exact picture of the bomb's flight as seen by the television camera mounted beneath the controllable bomb. This enables him to fly the bug as though he were actually in it. Notice the strong vibrations of the radio antennas on the bug now. A short time later, the bomb crashed.
And actually, as one of the things there, the antennas, one thing that they had to wait, part of it was that on the earlier block system, the antennas were quite large because of its low frequency of transmission. You'll see back there is that the antennas are quite small for the newer systems, and they were actually much, better for mounting on top of a small bomb. But that was the GM, the bomb you see here, there was, again, was a developmental prototype that they test the technology and to learn about it. The next in the actual production bombs was the GB4. And the GB4 was a glide bomb, and you can see mounted below the B-17, which is a 2,000-pound bomb with a wing attached to it, with a TV camera mounted beneath the bomb. It was actually used in combat, and you will actually hear later on the designer of that bomb and his recollections of when he went to Europe and flew missions on the experiences and things that he learned about all these when he actually did the missions. So just a little quick statistics on that bomb. So it's 12-foot 12-foot wingspan. It's about 6 foot long. It has 2,000-pound warhead. It used the Block 3 system, which is all the equipment you see on the table on the on the right-hand side there. Had a range about 25, 30 miles, probably mostly that over water. Many manufacturers were involved in the construction of it, as you can see. Cost of television equipment, it was $2,000 in in the 1940s. And the total cost of the weapon is, as you can see, $3,800. So the television certainly was the most expensive part of the entire weapon.
This missile is guided to the target by television equipment attached to the bottom of the bomb. Clear weather between the carrier plane and the target is necessary, for the objective is held in constant view on the television screen. When released, the bomb attains the speed of approximately 280 miles per hour. The pursuit for pinpoint accuracy is well on its way with this GB4. Though limited by haze and overcast, it is an excellent missile against difficult targets, such as bridges, dams, tunnels, and ships, for these objects are clearly discernible on a television screen. The GB4 tests have shown fair success. Further developments on this model have produced the GB15, which is expected to prove even more accurate.
That was actually, obviously you can see it was a test, and there was, had this little pyramid object that they were aiming at, and Joe, you'll hear his interview later on about his experiences with that, and daring things these guys did. It's kind of humorous. The next of the weapons that we used in combat was called the war-weary aircraft weapon. And so what they did, and of course the Navy had their version, which Project Anvil, Aphrodite's was the Army's version. And just a point of reference, also Joe Kennedy, who was, got lost in combat in one of these, in actually the Navy's version of this weapon that exploded over the English Channel. It was a television-guided missile that Joe Kennedy was on that he was flying, and they were used in combat, and in fact, that's actually a mistake, because Project Aphrodite's was the Army. He was in the Navy version, so that's a mistake. They were used in combat, and the goal was, and you'll see the next little movie clip there, is that you could basically take a whole entire plane, fill it up with explosives, and remote control fly it into a target. So Eglin was one of the big testing fields. There's Florida. Eglin was one of the fields where they tested a lot of these guided missiles. Tonopah, Nevada was another one. So they called it the War-Weary Project. And the idea was that you had these expended, bomber planes that, in essence, outlived their usefulness as bombers. They gut the entire plane out of anything essential, and then fill up the entire plane with explosives. So you can see here that here's a television counter mounted in a soundproof box in the nose of the plane. And in the control plane, they used also the word mothership. So you had basically the television receiver mounted in the mothership, which is what they called the controlling plane. Here, this is a test, so you can see, so they're obviously filling it with inert bombs. So they're filling it with an awful lot of explosives. In Kennedy's plane, instead of actually using, bombs, as you're seeing here, they filled the entire plane up with Torpex, which was an extremely powerful explosive. So they built all special racks inside the plane to house all these bombs. Also had to come up with a way of arming them. So they had this. You'll see here they came up with the idea of having a special fuse that they could use that could actually be remotely armed with, in essence, you'll see by a wire mechanism. One of the things that the difference here is that's an Army version. The Navy version believed in having electronic arming, so they had electronic arming of the weapons, where the Army had more of a mechanical system of pulleys and wires and such. And this essential system of actually controlling all these wires and pulleys and mechanisms, have one central way of have a lever to arm the bombs. So you needed to have a pilot and a co-pilot to actually launch the plane up in the air. That weapon, other weapons you didn't. This you actually had to do that. And you'll see that they're bringing the plane up into the air, and then And you see the mothership is trailing behind the weapon. And they would put the plane into remote control mode so that the plane could be controlled by the mothership, and then the pilot and co-pilot would bail out.
Parachute out?
Parachute out. You'll see them parachute out. And in fact, before they parachuted out, they pulled out the pins to all the bombs to, in essence, arm them. Here's the television operator with his joystick you see back there. Similar thing, he's actually watching out the nose of the plane and actually controlling the, that's probably a camera from the nose of the plane. Here, obviously, they're putting on their parachutes. And of course, I'm sure this is kind of Hollywood stage. This is not a real combat film. A little, you know. But see here, they pull all the wires, they're arming all the bombs. Bail out. So if you've been to the airport there, they've had one of these planes, you know, that flew in, you know, I think it's, you know, and you could just picture that whole entire plane filled with explosives, what kind of weapon that would be. And the idea of it being that they, you know, if you go, and they would use it against especially one of the big targets they were going after was the V-1 rocket bases in France, because they buried the bases in so much concrete that no weapon they had or no bomb could actually break through, you know, that much concrete. So the idea is fill up the entire plane with explosives that at 2,000 pounds would be, you see 14,000 pounds of explosives, should be able to, if you flew enough of them at it, should be able to break through the concrete. That was the goal. And you'll see here the kinescope record of that. What the television camera, what the operator saw. You know, you can see that. I mean, again, the quality is okay. You know, it's not the best of quality, but it's enough to identify, you know, objects and terrain and help narrow down the aiming of the missile. I don't think it actually worked very well when you're fairly far away from the object, because the point of view of the camera is relatively narrow. So you don't like looking out the window and you see this wide panoramic view. So it's very, very narrow. That's the WWII project. Okay, so the next weapon that was used in combat, this is a Navy weapon, it's called the TDR. TDR was a powered weapon. It had two Lycoming engines there. It was operated under the group which is called Stag One, which you can see Special Task Air Group 1. They were commissioned and they were operated out of the Solomon Islands, of carrying out attacks against the Japanese installations. And 46 missions were launched from the island, and approximately success rate of over 50% hit their targets. The little video you can see, and here's actually a little bit details on the weapon, and you can see it's much longer than GB4, 30 feet long, and has obviously 220 horsepower engines, 2,000 pound load. Used the Block 1 because the Navy had they were first ones into the, buying the systems from RCA. They had so many Block 1 cameras, I think they just didn't want to switch over to the newer technology, so they were using up the older technology in these weapons. and you can see many manufacturers were involved in creating the weapon. And here you can see the TV camera out the nose of the TDR with the bomb below. So here, this video here, Jim Hall was one of the operators for the in Stag One during the war on these weapons, and he wanted me to actually put together a little bit of video for him before he passed away to kind of show to his engineering group there about a little bit about TDR. In fact, he was the big proponent amongst, and you'll see his book back there, of actually promoting the idea of guided missiles. No one ever thought about it. I mean, it just no one. It was even the TDR was classified until like the '60s. It just was. They didn't ever release any of the information. So his group, and they felt it was such a, they did these things during the war, and they were so under-recognized that they developed this technology. It was in combat and this, that, and the other thing. And so he was one of the force behind of promoting it. They have their own website now. You can see not too many members left because they're all passing away. He wrote this book, and this is a little bit of what the TDR is about, and Jim Hall. So here are the TDRs in the base on the Solomon Islands. And you can see they look like a normal aircraft. You see they don't have a cockpit, but because they're totally meant to be remote controlled aircraft. They're launched from the ground, flown in air, remote controlled, hit the target. They do have, as you can see, they have landing gear, but I think none of them were ever. I guess you could have dropped the payload and flown the bomb back, but they never did that. They actually flew the entire bomb into the target as one-way missions, but they had the ability of doing that. You can see the TV antenna mounted out the back toward the tail of the plane. They did have the ability to ferry the TDR, so you could take the top hatch of the TDR off and put in a canopy so that you actually can control it. The Navy used TBMs as control planes instead of B-17s. And you can see here, because again they use green in the TV monitors because green is the most visible color to the eye, and of course when you're up in a plane and it's bright light, you're surrounded by white light, green actually stands out very well visibly. And you notice here, so you can see here the compass in the lower part of the screen showing heading. So that really was probably the first use of telemetry. And you can see it hitting. And again, this was also, it was a sunken Japanese freighter. It was in essence, all this was staged for, quote, filming. This is not a combat mission, but it gives a concept. And they missed. They even photographed when they missed, which you'd think they would cut that out and should be seen, but they did capture everything even the failures. Right, missed.
Didn't even explode.
And I think that's one of the things in general is that guiding, video games are a hard thing. So guiding things visually it's not that easy. And I think in the end, as a sole means of guidance, it actually didn't work because the technology wasn't still developing. The guidance systems were slow. When you moved the lever to the right, it took a while to move to the left or to the right, and everything was very slow, and it overcompensated. And the television itself was breaking up, and pictures weren't very clear, and it was hit and miss, and it was still learning. And this is still 44, and they were still learning. And you can see here they could put a canopy on top of the TDR, see for ferrying it from one island to the other. So it had the ability to have you can see it has controls inside. You had much of it, and it's a wooden aircraft. It came in the islands as kits. They were all I don't know how many crates they were, but they basically assembled the TDRs on the island as individual parts. And built these planes as sort of like you build a model. Had the idea of launching it off of a catapult. I think that was a concept that actually never was. Again, it was a concept never actually being used in combat. I think once you
For the longest while, I had called this book, and the original on the blanks, I had said Stag One, Stag One. And coming back from the reunion, that reminded me, talking about the War Witches. Coming back from the reunion in October of last year from Houston, I was sitting on the airplane next to a young PhD who was just coming back from Nicaragua, and he was, helping the peasants and all this good stuff. And we had an interesting talk. And naturally, somehow or other, the conversation got on to Stag One. And talking about airplanes and all that. And he says, boy, that sounds very interesting, but if Stag One, Stag Four, what does it mean? And he says, if I went in the store and I saw Stag One, Stag Four, I doubt if I'd pick it up. And he said, but you know what it sounds like to me is the kamikaze kind of airplane. And it sounds, I said, well, we were unmanned. He said, well, it sounds like an American kamikaze. I said, he said, now if you had that title, I'd probably go and buy it. Of course, I'm going to send him a book. But anyway, that's how the title came about, as a result of the reunion.
Wonderful.
And that's his book behind there. It's actually personal recollections of that Stag One operation, and they do have their website still is actually running. The next weapon, very interesting concept. I think it was a sales pitch. Never actually made it to combat. But it was the television guided boat, and you can see here it's a joint project between the Army and the OSS, and there was an interesting concept of basically taking a boat that you can mount the television camera at the nose of it, fill it bolt up with explosives, and have the ability in this boat to be camouflaged using different types of boats. You can see here different types of boats that are available, but also to be camouflaged as different vessels depending upon the location where they were, so that it would look normal, it would fit in with the rest of the locale. And again, I had the ability of having an antenna. You see the TV camera antenna mounted out the front there. Television camera at the nose of the boat. Similar, again, same block system you see on the table there. That was using the GB4. And I had a TV receiver and similar setup as the air weapons. And here is I would consider it more of an entertaining Hollywood production sales pitch of this weapon that they probably were selling amongst themselves or the generals, and because this is obviously top secret.
For deception purposes, Campbell lends itself easily to a variety of possibilities. As a fishing boat native to the area of operations, as one of the miscellaneous utility craft that crowd harbors, even as an enemy supply or light combat vessel, such as the German E-boat. In this case, the hacker was converted into a rusty, weather-beaten Danish Spritzel fishing boat. The job, aging included, took a week. The choice of the fishing boat disguise is especially apt for an OSS sabotage operation. No matter how thoroughly guarded an enemy-held harbor may be, the authorities, pressed for food, are forced to let the local fishing fleet continue operating. The missile, properly disguised, could be slipped into the fleet from a mother ship, from a submarine, or by OSS operatives working in enemy territory. Once inside the harbor, it would be guided by remote radio television control into the target. The hacker, converted into a Danish fisherman, rides heavy seas. The plywood hull built over the false frame takes the pounding with no sign of distress. The disguise, however, is not completed. To kill the giveaway speedboat exhaust, special mufflers are attached. The motors themselves are soundproofed by nailing thick layers of Celotex to the hatches. Provision is made to simulate the characteristic chug-chug of a fishing boat diesel engine. Motion picture soundtrack and sound head are placed on shock mounts under the false deckhouse aft. The strip of film is spliced into a continuous loop. The chug-chug repeats endlessly. Also under the false deckhouse is a mechanism which chemically produces smoke. The pot, not shown here, is placed under the blower. The alternate timer sends the smoke out in natural puffs, properly synchronized with the simulated engine exhaust. The bombs go in, 14 of them for a total explosive charge of 3,400 pounds. This boat, the A2, has a capacity of 5,000 pounds. Larger boats are available and can be used for Campbell. The A3 is 37 feet in length, 3 feet longer than the A2, but its beam is 11 feet 3 inches and it can carry 10,000 pounds of explosive. Like the A2, the A3 has a top speed of 35 miles per hour. The range is also the same for both, 300 miles. The ARB, however, has a cruising range of 2,200 miles. At top speed, 30 miles an hour, its range is 700 miles. The ARB is 85 feet long with a 20-foot beam and can hold 50,000 pounds of explosive. Any desired type of explosive can be used. Depth bombs, depth charges, aerial bombs, torpedo warheads, block TNT, cast Torpex, or whatever may be available in the theater of operations. For the gun run against the San Pablo, the missile is loaded with depth bombs containing Torpex. Top section view of the missile shows how the 14 bombs are fixed into position. The explosive effect of Torpex is 1.4 times as great as that of TNT. The television equipment is brought up. Left to right, conversion unit, transmitter with cabling and wishbone antenna, dynamotor, and junction box. The conversion unit is fitted into an acoustic box. The box excludes sound vibrations which might mar the clarity of the images transmitted. At this time, too, radio control equipment is installed. The B-17 used as the control plane is quickly fitted out for Campbell. Radio control equipment above. Below, the television receiver. The rubber hood attached to the screen cuts off outside light and permits clear vision. The plane takes off to rendezvous with the K-354. Two men take the missile out from the dock. The operator is ready to take over control. The crew of the missile goes overboard, is picked up by the boat from which these shots were taken. The missile is now completely under the control of the plane. Radio control is easily operated. Different officers take a hand at it. Guided by the television view of the craft's course, the operator steers the missile steadily on its way to the San Pablo. Left rudder, right rudder. Remote radio control also allows the operator to accelerate or reduce speed. A telemetering device fitted up on the missile is recorded by the camera. This device makes it possible for the operator, studying his television screen miles away, to know at all times how fast the boat is going. Remote radio control also allows the operator to stop the missile and start it again, to turn the diesel engine soundtrack on and off, to send smoke puffing through the stack, to set off the scuttling charge at any time. These aerial shots were not taken from the control plane, but from a second B-17, which kept circling the missile for photographic purposes. This is exactly what the operator sees on the screen of the television receiver. Note compass foreground, an integral part of the camera on the missile. The compass helps the operator hold a true course. These are actual, unretouched motion pictures of the images transmitted from the missile. They were taken from a second monitor television screen. As can be readily understood, the television images lose some degree of clarity in the photographing. The operator at the television controls sees a much sharper image. The San Pablo first came into view 5 miles away from the missile. She is now 1 mile dead ahead. At the actual scene, the missile rides low in the water, is not easily discernible. Middle right. The surface shots were taken from 2 boats anchored at different angles less than a mile from the freighter. The camera plane which took the aerial shots flew in a constant circle, 4,500 feet away from the target, 1,000 feet up. The run of the missile toward the target in slow motion. Target run. The San Pablo seen on the television screen from the bow of the missile as it goes right in. Scuttling charge. The depth bombs are going down. The hydrostatic fuses are set to go off at 30 feet.
So it's a weapon that I think that was an interesting concept, and I have yet to find it being used in combat. Just by the way, if you notice the little logo at the bottom there, that's actually a very good website. They have all these military videos online and very eclectic videos, and it's free to watch. It's a very interesting site. So the so that was basically all the weapons that were used in combat, some not in combat during World War II. There was so many block systems left over, because they built so many thousands of the systems, that the next use of them happened to be in Korea. And there was a unit formed called the GMU-90, the Guided Missile Unit 90, and they launched television guided powered missiles, which were TDR drone-like, from the USS Boxer. And they built 6 of them, which were built into Hellcat, basically obsolete Hellcat fighters. So they would, again, just rip out, the guts out of them, mount the 2,000-pound bomb below it, and under the wing with it is the TV camera, because you can't put a TV camera out the nose, because the pictures that you would get would not be useful. And this was, again, even back then in the Korean War, they considered this an exercise in learning about how how a guided weapon could be used. And so they really didn't have still much confidence in using them. And even after the experiences of World War II, they were still, I would say, tinkering around with them. And you can see here is that actually the television imagery is actually not as good as or as clear as the say the boat bomb, because again the boat's on water and the airplane's above it, and it's pretty much clear line of sight, very clear images. Here this is a shot being taken in a valley where the plane is again the plane and the missile are in this valley, and you're getting all these reflections from the surrounding area and causing the image to actually kind of break up as you see. So it had its limitations in quality and technology, and basically after this point there, the block system was obsoleted. I think not until the Vietnam War did television-guided missiles start making their appearance again. And you'll see here that this is actually, which is not a very good picture, but they're actually trying to bomb a dam on a river. And here you get a good shot of that. See here. This is obviously the photographic ship, and somewhere there it is, right there. And that's quick at that. So what is the conclusion of all what you've seen and heard? So television, did make its appearance during the war. Most importantly is that it, what the government paid, the manufacturers, RCA being the biggest beneficiary of it, is all their developmental dollars to develop this technology, actually what made post-war television possible. Image Orthicon 2, prime example of it was developed for military purposes, and millions and millions of dollars were spent by government money that the company didn't have to spend, and basically they commercialized television from that technology. And as you can see, it was still a learning experience in weaponry. They had limited success about it. Television sounds like a novel concept, but even with the TDRs, Jim Hall would tell me that they also had a radar beacon on the TDR, and they could be able to track the TDR by television and by radar. They tended to favor radar more than television because they felt it was much more reliable, much more accurate. Just seems like a better technology. And even the Germans. I didn't want to talk about the other countries using it, but even the Germans were tinkering around with television here, and they were come up with the concept of a television-controlled tank. Whether or not that was used in combat, another question, but it's certainly going to be talked about in Bart Everett's book that's coming out. And there is more information about the technology. They have it on the Victor Amateur Radio website there. There's a whole page about all the TV equipment and more technical details about it. There is a little printed version of it if you want to take away some of it here. And again, there's a lot of people were involved in in my research and collecting all this information. And certainly Bart Everett was pretty important, and here's that website there, Real Military Flicks. It's a pretty interesting site to put on your iPad. So here, here's I did to the director of the Tonopah Museum. This man named Joe Pomikata. He was the engineer that Wright-Patterson hired basically before the war to design the GP4 weapon and take the weapon to Europe to fly it against enemy targets, and he was there first-hand account. And here's a little piece of his interview. How did you come up with your idea for developing the GB4, and how did you get it implemented?
Well, the Air Force wanted a radio television control bomb, and we started out the aircraft lab at Wright Field coming up with a design, but it turned out that there was not enough space in the fuselage to carry any radio control or TV receiver or camera and so on. So I came up with the idea of a GB4 with a fuselage at that. I came up with the original, with the design, which I then took to Tim Aircraft, and they did the detailed engineering, and they did all of the production drawings and so on for us. And then we took that to the furniture factory in Vernon, California, the Klassen Company, and produced the airframe.
How did you come up with the design concept for the airframe and the fuselage to make it?
Well, from my experience working for the aircraft industry before I went on active duty, I knew that we should use something that was shaped by using thin layers of wood molded over a form and so on, so we could have a stressed skin type of airframe.
Now, on your Eglin tests, those were conducted out in the ocean at targets?
No,
They weren't?
That was overland.
Over land, okay.
Yeah, they had some bombing ranges or whatever. They're in the middle of this. They would have a wooden pyramid, and that was the target that they used for their own tests.
Oh, for the GB4.
So we used the same thing for the GB4. And of course we had trouble developing the flight control system, the gyro system and so on. And we went through a learning process where we had cross controls. We'd call for down control, nose down, and then the thing wouldn't respond to an up control. Well, it wouldn't respond right away. So we had a case there where we dropped the thing dropped them from a B-23, and we gave it a down command, and boy, it just nosed over, going straight down. So pulling back, get it back up. Well, it finally responded to that and just turned and came right straight up and up in front of the airplane, and then leveled up and came back down, just right in front of the nose, And it amazed me that it, reached a higher altitude than the one at which it was released. But of course, then you had a in dropping the bomb, you had imparted some energy to it there that it had, which it then picked up on the way back. Then we finally got it back down and down again. So we went through that kind of thing. When we finally discovered what was wrong in our control system, we had that ironed out. Then we continued with our tests. And one test, General Arnold wanted to see a demonstration, so he came out and, and they scheduled the thing for, I think around 12 o'clock or 1 o'clock. Anyway, so Colonel Holland said, oh, get everything ready, get up in the air and be ready. So we got up there at the scheduled time, and and he was supposed to come out to the range and witnesses. And we flew around and around and around, and he wasn't showing up. They were having lunch down there, and they had just had a long lunch. When they finally came out, we'd been up in the air for about over 3 hours, I guess. So when they finally, the party, parked at the edge of the range there to watch this thing, and we let it go, and we flew right over the top of General Arnold's party, and it's just beyond the pyramid, but he didn't realize how close he came to being hit.
How about Lauren Hammond of Hammond Organ Works fame? His participation in what his company was manufacturing during the war years, and he came out one time for the actual drop tests. What can you tell me about that?
Well, he used to come out. He worked very closely with us, and he's the one that developed the gyro control, and then also the radio control box. You see, we used there was the BC series of
Command sets.
Yeah. And we used that to get the radio transmission. But then we had to feed that into a box that would turn that into the commands for the airfoil surfaces, the rudder and the elevator. And Hammond developed that part of the system, the box that take these signals and feed the instructions out of the servo units that operated the control surfaces.
So when you were flown out to England, I understand that you were kept in isolation from the rest of, the groups on the base as more of a...
Well, we were assigned to this auxiliary field, first field, and the only people that were there were our project and the Aphrodite and the Navy, Joe Kennedy.
Your first mission from England was, can you describe the mission, that the first one you went on, and what the problems and issues you ran into when you did it from England?
First mission?
Yeah.
Well, the first mission was against these E-boat pins at Le Havre. And, of course, the television reception in the airplane was almost nil, so we just lost 2 bombs there. The first one, we didn't see where it went. I mean, we didn't get any pictures back. The second one was intermittent, but what we got was after the bomb had passed over the target and so on, and crashed on the beach.
The television failed, but how about the the guidance and the rest of the functionality of the bomb? Did it meet up to your expectations.
Well, you couldn't really tell. If you didn't have the television, you didn't
Couldn't see.
have anything to do. And so now the observation airplane that came along, and their TV reception was good. They got pictures back from the bomb, but of course they couldn't do anything. They had no controls. So the problem was in the planes that we had. Anything like loose washers rattling around or would cause interference and ruin our reception.
How much time elapsed before the second mission, and what was the second mission that you went on?
Well, I have to look at my diary to see how much time elapsed. I don't really remember because there were delays and so on. And the second mission was the mission against the sub-pins at La Police and La Rochelle, France, which was way around the end. And was there again, we carried 2 bombs and we had the same problems. Well, I think one of them, the shutter didn't open, the first bomb. I may be wrong, but I think that's what happened. Anyway, we didn't know where that bomb went and couldn't control it. The second bomb, one problem was we could, with 2 bombs, we could only get 17,000 feet in altitude. The plane just couldn't get us any higher. So anyway, the second bomb, we would get these intermittent pictures, and most of the time we had no picture. And when it passed over the coast and over the sub-pins, the picture we received was transmitted after the bomb had passed over the coast. So it came on, it was over the, I don't know which city it was, whether La Police or La Rochelle, but one of the 2, and we were right over the city. And so there was no target of opportunity. There was this city, and so I could see that there was this open area, it must have been town center, and so I just nosed the bomb over and bring it right straight down without going out in the more populated area. And so the last thing I saw was this scene rotating as the bomb was spinning and going down.
So you basically made a conscious decision that you didn't want to have the bomb drop on civilians.
Well, yeah, I didn't want to, but it was the lesser of 2 evils. Do you hit a congested part of the city or something that's open? You don't have much time to really decide. So afterwards, we only carried 1 bomb so that we could get more altitude. Plus the fact we only had 3 bombs left.
Third mission with 1 bomb, what was that target?
That was the target during that was a transformer switching station in the steel plant at Durin. And that was where we ran into clouds again, but we dropped, and when we came out of the clouds, we had gone over the town of Durin, and the only thing was open countryside with a big building on the left side of the road that was. And as I got nearer, it looked to me like it was maybe a big school building or something. So I had enough time to get off of it and brought the bomb over, and the only other thing in sight used as a target was this big tree, like a big oak tree. And that's when I said, all right, fellas, just to show you I can hit something, I'm going to hit that tree. And that's what I did.
And you hit the tree.
Right at the base of the tree.
On your two B-17s you were assigned, your team, now you had them for the test drops at Tonopah, then you went over to Ferrisfield, and you lost one of the B-17s. Can you tell me something about how that took place?
Well, we had the two B-17s at the first field there, and there was a crew from the base of Nadishaw, and for some reason they, I think, took that B-7, borrowed that B-17 to get back to the base or something. Anyway, I don't remember exactly why they were taking it, but they flew it back to Nadishaw, and as they were coming in from for a landing, the prop came off.
Wow.
One of the engines and crashed through the airframe, the cabin, cut control cables and all that sort of thing, and of course the plane crashed, hit the, ran into some other, I think another airplane on a flight line, and also trucks and vehicles. And I don't remember just exactly how it got out, but there was one member in the back of the plane. He didn't make it, so he was lost, and then of course a few people on the ground were also.
Then you were down to one B-17 then.
Yeah, so that we were left with the one B-17.
So other than the skillful aiming of you hitting a tree, sounds like no combat success yet.
No, really no success at all. I guess the last mission, and I hit a church, and I did some, had control response there. I could have gone in right in the front door, but I tried to skip over and I didn't quite make it.
On the last mission, after you expended all your bombs, that
Well, we had one bomb left, but the weather just grew progressively worse. We had we couldn't, I think for about a week or so we tried to get another mission, but couldn't because of the weather. And then, so then we had orders to come back to Wright Field and leave that bomb and the, 6 or 8 GB-8s for the English. Well, what I was learning was that we were still having a lot of trouble with the TV in the airplane. And actually we were ordered out of Tonopah before we really had all the problems solved in the reception of the TV signal in the airplane.
It was, as you can see, as you can see, a unique man that was the designer, flew the missions himself personally, and had a conscience not to hit civilians.
This isn't really known that much. I think of
It's-
this type of thing in the
As
first
it-
Gulf War. That's what we saw on TV. I don't recall anything
Exactly.
in Vietnam that
It's,
really-
I mean, you certainly know about it today with Predator and the UAVs, and it's certainly it's a common thing, unmanned aircraft, a common thing today. But it's you didn't. No one ever talks about the where it started and the greatest people that were. I mean, like I said, the engineer that goes out, that designs the plane on the base there, is actually going on to missions and flying his weapon. Could have been killed. I mean, just in enemy territory. So and they didn't have much success. They were still learning. They were rushed, like you say. Tonopah was the base where they did all their testing, before they were shipped out and to the theater, and they didn't have the bugs worked out. They said, "Let's go," time's ticking, and then all this rushing and development things were happening in a very fast pace and developing and fixed, and they just couldn't get it all worked out all in time.
It seems like the Axis just used it. You just mentioned the tank that they had. Was there any other?
Well, certainly. That was the Germans. The Germans also had TV-guided missiles themselves. They had fly-by-wire missiles. They had before the Americans. There were a lot of it was used in reconnaissance. They used the television for reconnaissance, but the actual missiles that were probably more of the Americans than anyone else, that were just gave it to every one of these divisions, Army, Navy, Air Force, and the research divisions. Okay, what can we do with this? Try it out. Try different concepts. Try, see what works and learn from it.
Yeah, that's really what it seems.
Learn from it and see, and in the end, I think that they all somewhat learned, and that it didn't work very well. It's a difficult thing to control something two-dimensionally and not have the scope of what you're.
Time delay also.
Time delay, there's reaction time, it's slow technology, it reacted very slowly, it was in its infancy. It's like cars in its infancy, it's a technology. It looked, the convenience we have today was not the way it was 80 years ago. It was a learning experience and evolution of time. So now, obviously, when they fly out the Predators and UAVs, I think they're doing it from Las Vegas, Nevada. They're flying it out, and that's where they're going into Iraq, and they're thousands of miles away. They don't even see their, GPS and television and radar. They're using multiples of technologies to kind of make it, and obviously the success rate is fairly good.
Yeah, they have that account there for a long time.
Right.
Yeah, so first real success seemed to be the Gulf War. Is that right, or was it?
They started using it in Vietnam a little bit. They used it in the Gulf War with started using TV-guided missiles in the war, because you can see enough footage of them being used. But it was again it's a point. They used it as a point of information. They didn't use it as a sole source of guidance. They had other means of guiding these weapons. They were trying to use it as a sole source of guidance, of dropping it and then guiding it to the target. And the Navy guys said we didn't trust it. We're using radar too, and the radar actually, the radar and the TV guys sat side by side and ended up. Even talking to Jim Hall, they would almost at times peer out the nose of the plane, see where the missile was, because they wanted to visually track it, not, you know, he is a short interview for Joe, but one of the things that what they did with the GB4s in Europe is that when they dropped the plane, the B-17 flew in the opposite direction, away from the bomb, so that they would get away from the blast, which means that you only were sighting it by television. You were not sighting it visually.
Right.
So it, you know, and it depended on that technology to be reliable, and it's you know, wasn't.
Enlightening.
Something else we didn't know.
Thank you, yeah.
All right, thank you. Thank you for coming. Standing there as the video operator, as you know, tuning them in. Over the airwaves, locking them in. No AGC, no automatic controls. Getting nipper tuned in. Of course, the television, the Bombardier. Yeah, his image already squared up.